Hey everyone, my name is Mike Walteri. I'm a principal analyst at Forrester Research, and I cover streaming analytics and other forms of advanced analytics. Really happy to be here today to talk to you about streaming analytics, to demystify it, and to show you how you can use it in your applications. So let's get started. Streaming analytics always begins with data, and I just want you to think about data for a minute. If you think about it, data is a bit like a drop of rain. It forms instantaneously in a cloud in all of our application centers, but most of the analytics is done at a much later time. The problem with that is that it's not real time. And the reality is that all data originates in real time. And I want you to think about this because this isn't the way most people think about it, especially in doing analytics. They think of the data originates when it makes it to, say, a data warehouse, or it makes it to some other database or data source or a file system. But the reality is when someone clicks on a button, when a sensor releases a temperature, all that data originates in real time. And the old thinking is that the analytics to do that takes far too long. And the problem with that is that it's not meeting the business requirements. So we did a survey here, and we found that what most people want is faster performance, faster time to value, and to use advanced analytics capabilities, and you can see they're predictive, prescriptive, and streaming. So these are key drivers for application developers. So the point is we don't have to wait. There's no reason to analyze this data later. We can analyze it now. That's what streaming analytics is all about. Now the thing is that insights are perishable. So we're not saying that data is perishable. Some people have drawn graphs and they've said, oh, data loses value over time. Not necessarily true. Insights certainly do, though, right? Because historical data can be used, for other types of historical reporting, creating machine learning models. But insights are surely perishable. And if you look at our perishability framework here, you can see there are different types of insights. There are these real-time insights, and those can be sub-seconds to milliseconds, sometimes microseconds, but even minutes, right? Because real-time means business time. There's operational insights, there's performance insights, and there's strategic insights. And you can see a little example here. If someone's shopping for furniture right now, the action right now may be to recommend cleaning supplies. On the other hand, in strategic insights, if that furniture demand is high, then a strategic insight would be to expand the product line. Most companies have focused on this squishy middle of insights, the operational insights and the performance insights. Those are your reports. Those are your reports and your dashboards. But what about those insights? So most organizations have focused their analytics efforts on this squishy middle of operational and performance insights. On the strategic insights, they've used their gut instincts, and largely real-time insights have been ignored. And a key reason for that is the lack of technology with streaming analytics. So when you're doing batch analytics, that data originates, the analytics are performed, the insights are gleaned, some decision is made, some action is taken. That whole cycle has to be pulled up, and that's what streaming analytics does. It compresses that analytics cycle for real-time insights. Now, it's not saying that you still don't need the historical reports and the dashboards. You do, but real-time analytics has been a big gap for enterprises. So, people can have very philosophical arguments about what real-time means, but it just means highly perishable. So if a customer walks into a shopping mall, real-time means 30 seconds. If a temperature sensor spikes, it could mean 1 second. If a stock price rises, well, that could be microseconds, actually. So don't get caught up on real-time. It just means right now, defined as the business requirement. So what are some examples of these real-time insights? Well, if someone's shopping now, based upon that click-through, is there some sort of offer or gentle nudge you can make right now, not later in an email? In the world of IoT, certainly vehicles have technology to detect the slippage in a wheel. and that's certainly real time and can alert the car. But what if it could also stream that information to other cars a mile behind to avoid a crash by those? Financial services firms are using streams of data, real-time data from social media to look for potential stock risks or opportunities. People are also using streaming to detect customer SLA problems, and they're doing it right now. So there's many examples in any application that you can think of where there's streaming data that can capture these insights. So the only way to do this, though, in an effective and scalable manner is to use streaming technology, and that's what you can use in your apps, in your applications to detect and act on these real-time perishable insights. So what exactly is it? Well, it's streaming analytics, and the word analytics is a little bit problematic, not because it doesn't do the analytics, but because it does more than that. It's very action-oriented. So these are analytics that are being used to then make decisions, detect actions, trigger business processes, and other applications. So at its core, streaming analytics technology ingests, analyzes, and acts on a high-throughput data from multiple live data sources. It can identify patterns, very complicated patterns. It can detect situations. But this is the key. You use that to automate immediate actions. So you've got real-time data, but then you've got analytics that can lead to the real-time action. So streaming analytics is an analytic platform. It's also an execution platform. Thinking in streams for developers is very different, especially when you think of analytics as making a query and getting some results. The best way to think of it is that it's a continuous query. So it's continuous ingestion, and let me stop right there, because streaming is a word that is used a lot for other technologies. So for example, Apache Kafka is often associated with streaming. Well, that is very good at this ingestion side, but it does not do the analytics side. So you have to be careful when you're looking at streaming solutions. There's a big difference between just streaming or stream processing, which is often about delivery and some light transformation, versus the analytics. Now, on the analytics side, the analytics are about correlation. Can I create a geofence and detect when something enters that? It's about time windows to detect spikes in data. Maybe the vibration and temperature of a large machine spikes up, and that indicates a problem. Or maybe the number of tweets about a certain topic has increased over a short period of time. And some of you may know the old term CEP for complex event processing technology. CEP is a feature of most streaming analytics platforms as well, and that's used to detect complex patterns. And of course, as I indicated, streaming analytics is not just about the analytics. You can put predictive models, business logic, and certainly trigger actions in other platforms. So when you're looking for a streaming solution, there's some typical characteristics that you have to look for. We've been talking about data, but it's probably a good idea to also think of data as events as well, because streaming data often represents some event that's occurred in another application or in a device, for example. So the streaming applications have to understand any type of information that comes from any of your systems. It certainly has to scale to handle spikes. We think of streaming data, most people think, okay, this is just like data coming fast as possible. Sometimes not. Sometimes it comes in dribs and drabs, and then there's a spike. And so it has to be designed to quickly handle that sort of spike in data as well. Most of the data sources with an enterprise or application, there has to be some sort of security to protect confidential information when it's within the platform. And like I said, this is not your sleepy old, I'm going to do some analytics, produce a report or a dashboard. These are execution systems they get inserted as a critical component of mission critical. So they also have to have a degree of fault tolerance. And that's not so easy, because for streaming analytics to be fast, it has to be in memory, and there's lots of state that has to be kept in that memory. So the architecture of these platforms is not trivial, and that's why it's its own category, analytics category in itself as well. This is not just about processing an event and seeing an event exists. These analytics are stateful. They're stateful analytics. So if you're looking for an average temperature over a minute, that's stateful, because you have to keep a time window. So in order for you to truly understand what streaming does, the time windowing concept is very important. So these are stateful platforms as well. Again, that makes everything else, low latency, HA, pretty difficult. And you also have to be able to leverage skills that make it easy for developers. Now, there's numerous platforms out there. Some of them take the approach of using SQL with extensions so that you can do real-time analytics by creating what I characterized before as a continuous query. So don't think of the SQL as a SQL statement that queries something and gets an answer back. No, this is a SQL statement that stays. It's live, right? And it's doing those analytics. Other platforms have their own, have invented their own programming language, and others still have sort of a drag and drop type of interface as well. But it has to be easy for developers to use it. So with that, I'd like to bring Roger Barget into the conversation. Roger, are you there?
Yes, I am, Mike.
Hi there.
Good morning.
Yeah, so let's jump into some of the discussion about some of the questions. So we have seen, or I have seen in my work as an analyst, that streaming has become very popular. It's driven by more sources of real-time data. It's been driven in the past by mobile. It's driven, even higher more recently by IoT. But it's also gaining popularity as a choice in the cloud. What are you seeing in terms of adoption of streaming in the cloud?
Yes, Mike. So what we've heard from our customers that are using Amazon Kinesis is they appreciate that they can pay as they go. They only pay for the resources they use, because, as you noted, streaming workloads can be highly variable. And they appreciate they don't have to provision or manage any resources, because these are fully managed services. And these services can dynamically scale because, again, data, as you mentioned, can stream in drips and drabs, or it can stream in surges. And they also appreciate the agility. They can use other cloud services to store this streaming data, to analyze it, or even write their own applications on EC2. And it's secure for them. So these are some of the reasons our Kinesis customers are using our services.
Yeah, I think another important point, in addition to the spike in the scalability, is what we've seen in talking to people. They may start with a few streaming sources for one particular application, but then they augment it. They add another streaming source, and then there's other applications. So I think that's another driver from an infrastructure standpoint, a deployment. Most of these systems, at the scale we're talking about, this isn't sort of a one server, one instance deployment. It's multiple. It's a cluster. It's a cluster architecture.
Exactly, especially when they're putting it into mobile applications. They have no idea how viral the application is going to become and who's going to be installing it and where that data is going to be coming from in the world.
Yep. So I think this question here is a good question about what it takes to implement streaming analytics. I think there's a sort of something else prior to this, which is what I presented about thinking in streams. A lot of developers have to also think about, okay, what could I do? What could I detect? So there's a whole business requirement part of this as well. So, but moving beyond the business requirement, and assuming we have one, what does it take to implement streaming analytics on your platform?
Yes, just as you mentioned about, you have to think differently about how you process the data. You really need a different set of analytical tools, because streaming data is going to come in at an incredible rate that can vary up and down during the time. And if you ask, what are the key requirements? And a lot of this maps to what you were talking about. You need to have a way of durably ingesting this data. This is business data. You want the insights out of it. You can't afford to lose it, and it has to scale. And this end-to-end processing has to happen continuously at extremely low latency. You have to transform the raw data, depending on what business questions you're going to ask. Then you can analyze it. Then you can react to it, take some action. Again, it's all about taking advantage of that insight. And again, the data doesn't lose value. You may very well want to persist it, put it in some archive for later processing. And it's these observations that have motivated why we have built the Kinesis data streaming services and their features. We have 3 services in market today. The first is Kinesis Streams, and it allows our customers to capture and ingest streaming data at extremely large scale. Our second service is Kinesis Analytics. It is doing continuous queries with SQL that allow our customers to process their streaming data. And then finally, Kinesis Firehose, which will allow a customer to deliver that data to a number of destinations in AWS. And these can be used independently. For example, Firehose can actually connect to a Kafka stream. Customers can ingest data to a Kinesis stream and process it with Spark. So we intend for these to be used together, but customers can actually make their choices about how they do it. And we've actually thought about who these are built for. Like Kinesis Streams is for technical developers. We provide a library so customers can use Python, Java, Go, Ruby to actually write their own custom streaming application. With Kinesis Analytics, we want to make this really simple for data scientists and business analysts. So we expose ANSI standard SQL as a way of customers expressing the logic for their application. And then with Firehose, we realize you may just simply want to get that data loaded into Redshift, for example, and hook a Tableau dashboard up to it. So we've really made it accessible for all developers to just create a Firehose delivery stream, tell us where that streaming data should go, and we'll deliver it in a timely manner to that destination.
Yeah, so let's look at sort of the mechanics of how streaming analytics works. I mean, at the basic level, it starts with data sources that are live. And as I argued early on, I argued that all data is live. It all originates in some real time. It's just, are you taking advantage of it? I think the other comment on this is how streaming analytics works is there are different users, as you mentioned. There's developers, there's business analysts, and so there's different use cases. I think the most underserved role is developers, because I think sometimes when developers hear analytics, they're like, okay, yeah, that's the business intelligence professionals. Yeah, but as we discussed, streaming analytics is analytics, yes, but it's about making apps real time. So from your perspective, how do you guys look at the entire streaming analytics workflow?
Sure. Well, one of the things we've noticed is a lot of companies are doing analytics today. And if you think about, are they going to actually retool everything from day one? And the answer is probably no. They're actually going to slowly work their way into this. And so if you look at what Firehose does, and we talk about it delivers streaming data, it captures it. You can transform your streaming data using Lambda inside of the service and then deliver it within seconds and minutes to an existing AWS service or some other service. And then the dashboards that you've already got written in Tableau will continue to work just like they were before, except now you're doing it in real time. And so loading data into data sources is a very common use case we see, and this is where the role Firehose plays. And again, most of the customers' workflow continues to be implemented just the way it was before, except with Firehose. Now they're moving into real time. Another pattern we see is, like you said, the developer. They want to use Spark on EMR. They may want to write some custom code themselves, or use Lambda and go serverless, or use Kinesis Analytics. And in this case, that's where the role of Kinesis Streams. They can ingest their data into a Kinesis stream and use any one of these options at their disposal to actually process and write their own custom logic, build their own dashboards. And so a lot of our highly technical developers are doing exactly that. And then most recently, we released Kinesis Analytics. And again, this is where they can start the service, they can connect to a Kinesis stream or a Firehose, both of which are doing ingest, and then they can write their ANSI standard SQL and stream that data out to a destination continuously. And it's worth taking a little closer look of what we've done here, because we do want to make this easy. There's actually 3 simple steps for actually setting up an application with Kinesis Analytics. The first is our customer will connect to a streaming data source, and it could be Firehose or a stream. The formats we support: JSON, CSV, variable column, unstructured text, and the service will attempt to infer a schema after it's read a few hundred records, and it will interact with the user to name the columns, the user can override the types. They can even tell the service as part of the ETL process, drop a column. I don't really care about that for my analytics. And once they have that done, now that data is streaming in and it's being transformed through the service. We skip over to the second step, which is they can write ANSI standard SQL over these streams of data, except it's windowed, as you pointed out, and build their analytics functions, chain these SQL statements together. And then finally, once they've built that continuous processing pipeline, tell us where they want that streaming data to be pumped out. Once that's done, they've built an application end to end. And to make it, go ahead, Mike.
Just go back to that other slide for a second, because I just, for the developers here who know SQL, just think, how would you do this? Okay, it's real simple. Let's just say we are getting a temperature in. I'm just overusing temperature, but say we're getting temperatures in from a sensor, and we want to know what the average temperature is over a 5-minute period.
Yep.
Okay, so you've got all this temperature data coming in, it's writing in, and you want that data. So right now you're probably thinking, oh yeah, I could write a select statement to do that. But that select statement executed in a traditional database would have to do polling, right? You'd have to have a big old loop, and it would always be behind, right? So the way to think about this, so we're saying SQL here, but when we say continuous SQL, it stays in the execution of the engine, and it's continuously creating state to do that. Polling would just bring any database to its knees. So this is traditionally how in the past it's been done without this technology. So it really is a different approach.
It really is. That's a really good point that you make there, because again, people, if you think about it as polling, it would be impractical to build such a system, it's the beauty of these continuously processing SQL engines. In fact, a lot of people, even those that know SQL, will actually say, well, what can you really compute with SQL? I've never thought about this. You can do simple counting. You can do counting with windows, like you were saying, any aggregate function over a windowed period of time. You can set alerts. You can detect patterns in your data. You can track an item through the airline or through vehicle tracking. And you can also detect trends, rise, fall. We've added machine learning to our Kinesis analytics to actually detect anomalies in data as well. So there's a rich number of things that you can do with SQL. And I think almost any analytics function can be written in SQL, except, as you pointed out, it's much, much more efficient if it's streaming SQL. To make it a little bit easier, we've actually added templates. We expect some people will be slightly familiar with SQL, but if they look at these templates, they say, oh, I want to do a sliding window operation. Well, we have a template for it. They click, the SQL is generated for them, and they can then tune that SQL. And this is why a lot of our customers are able to get their application built in their first attempt and actually go into production in less than a week.
Yeah, so let's look at some use cases. Let's look at what segments, what makes sense. Where's the uptake coming from?
It has been an exciting, as you've probably witnessed yourself, an exciting couple of years, because very early on, it was really the very tech-savvy companies that were using streaming back in the day. But as we look today, almost every application use case where data is being continuously generated, we're seeing stream processing applied. And we've noticed something kind of interesting. And we see this in ad tech, IoT, gaming, consumer online, operations monitoring. And there's an evolution. We often see the very way that customers wade into this is they'll just try to accelerate their ETL and load their existing databases or load their services. Then once they get that under their belts, they'll actually start doing continuous metrics generation and try to respond in real time to what's happening in their business or on their services. And finally, in the maturity model, they start actually saying, hey, let's go ahead and put some machine learning. Let's actually use some pattern detection, some forecasting. So really, all application use cases, continuously generated data, we're seeing them using stream processing technology. And it's really, where are they on that journey at this point?
Yeah, and I think that was interesting to point out that this technology actually did get started on Wall Street for algorithmic trading, and to detecting things in real time. But it does extend, especially now as the world becomes more real time. It extends digitally to all of these other applications. What are some specific examples that you're seeing with your customers?
So the one I always like to start with, and I think it's just enjoyable, not only because I like sushi, but when you start realizing that companies that serve sushi are embracing stream processing technology, you realize that it's getting market penetration. Kaiten Sushiro, a chain of sushi restaurants in Japan, Well, they wanted to have real-time insights into, they want to be able to order a fish from the dock when they realize a restaurant is running out. They want to see what is selling at what time, and when that way they can run experiments through the restaurants if they find a popular dish. So they really wanted to deliver a better experience for their customer. So they put small RFID trackers on their plates of sushi. They knew exactly, and they have a PC. It's collecting this information and streaming it to the cloud into a Kinesis stream. And they have a dashboard at their headquarters, and they see exactly what's selling, how long it sets on the conveyor belt before it's picked up, what's hot and what time of day. So they've really been able to improve their operations and better serve their customers through stream processing. So just-in-time sushi.
Yeah, talk about perishable insights. I can't think of anything more perishable than fish, raw fish.
Exactly. And another one, it's actually changed how people are managing their applications and building it. Amazon Game Studios, they're building a massively multiplayer game. They're continually adding new levels, new games, new experiences, and they want to know, how did players do last night after we've rolled out this new change, and how should we develop the next level? And so they can capture all the data from all of their users and all their playtime. They see how long they played. What we're looking at here with this graphic is for the level you just saw. You're seeing how long, where people died at on the map. And of course, they expect some areas to be hazardous. They expect other areas on the map to be safe. They can look at the engagement, and they actually generate streaming SQL queries to compute these metrics, to build these dashboards that you're seeing here, and they can see exactly how the gameplay is unfolding. And then they persist it. They archive it for years for analytics, but they can jump right in and actually fix a level or design the next level a little bit better if they see the engagements dropping off, or they've made the level too difficult. So they're actually doing just-in-time game development based on what's going on with their players. Another example that I really like is Hearst. Hearst is a publishing company, and many of us probably subscribe to many of these magazines. And when they moved into the digital world, they wanted to understand, what is their engagement? What are people reading? How is it trending in social media? So they built a platform called Buzzing at Hearst. And what you're seeing here is you're seeing individual articles. You're seeing how they're trending in Facebook, what people are saying, just doing sentiment analytics on Twitter, and how long people are reading them. And what they can do from this platform is that they can redirect content from one magazine to another. If they see an article is trending positively, they can commission a follow-up article or make a correction to the article or publish it to other magazines where they know the readers are interested in the same thing. And so they're able to really improve their engagement with their audience for the content they're generating and do just-in-time content generation. And they've seen their engagement with their customers go up. More people are visiting their sites. So really, they've retooled their business based on streaming, the insights they can get from streaming data. And just to pan back, I don't want to go into all these, but we have customers everywhere from Netflix, Lyft, funnels all of their production data through a Kinesis stream. Nordstrom, a traditional retailer, is getting real-time insights using Firehose to load a Tableau dashboard. AdRoll and AdTech gets 50 millisecond response time for over 50 billion ad impressions per day. Major League Baseball, Sonos, again, as you mentioned, the opportunities for streaming are abundant. Everywhere we look, we're seeing people applying this technology.
Yep, thanks, Roger. Yeah, and ultimately, streaming analytics is about time. It's about just-in-time. And I don't want to say just-in-time insights, because it's not just about the insights. It's about those decisions and actions, those non-perishable insights. So everyone's always talking about, how can we get value out of our data? Well, think about using those insights in real time. And most companies are just wasting the opportunity of real time, and it can be used to your advantage. And our view of the market is that it's only just getting started. It's still at the early nascent stages. So that's we're finished with the main part of our webinar. I believe we're going to go to a Q&A. So I will turn it back over to the host.